Hi children, this is your physical science facilitator SS from Commando Group of Schools. Welcome to the online classes. Dear students, in the last session we learned up to total internal reflection. Total internal reflection. When the total internal reflection takes place, if the angle of incidence is more than critical angle, means angle I is greater than angle C. If you understood the concept, then applications are very easy to analyze. Now, let us see that applications of TIR, total internal reflection. Among them, the first one is about the brilliance of diamond. The first applications, of course, applications of TIR. First one is about brilliance of diamond. Brilliance of diamond. Here the question is going to ask like this. Diamond is very bright because of its refractive index. Can you support or not? Certainly you have to support, because its refractive index is about 2.42, very high. Besides that, one more thing is there, less critical angle, very less critical angle. About the brilliance of the diamond, the refractive index is about 2.42 on an average, and the critical angle of diamond is just 24 degree, just 24 degree. So very small critical angle is there and very high refractive index is there. Because of these two regions, diamond become very precious gem because of its brightness. The brightness is because of refractive index and less critical angle. Why less critical angle means what happened? If the critical angle is 24 means from 24 to 90 degree, whatever the incident angle you are going to take more than 24 to 90. So plenty of angles are there. So many angles are there. So whatever the light incident in 25 degree, 27 degree, 28 degree, 30, 35, 40, 50, 60 like that up to 90 means multiple rays may fall on the diamond and multiple reflection is going to take place. That is the reason why diamond is have very bright and brilliance, because from 24 to 90 so many angles, so many incident angles may be projected towards the diamond. So multiple reflection will take place, so that the diamond becomes as precious. Of course, you can experience if you have the diamond. Once you focus in the middle of the room and focus the light on the surface of it and observe the screen, white screen, then you can see the multiple reflections because of this least critical angle from 24 to 90. What happened here? TIR is going to take place. The brilliance. Of course, Hallmark will ask, what is the reason behind the brilliance of the diamond? TIR. Because the critical angle is 24, no. More than that incident angle is nothing but TIR can take place. After critical angle, what happens? The refractive will increases with interface. When that is more than that, immediately it will bounce back to the same medium. Okay, so multiple reflections will take place because of this TIR. So the diamond become very precious gem. Right, that's about the brilliance of diamond. So what are the reasons? High refractive index and less critical angle, and multiple reflections are going to take place. Another one is there about mirrors. Mirrors. How the mirrors are formed? Okay, commonly 4 mark question or maybe 2 marks. And half mark they will ask like this: is it possible to take the photograph of a mirrors? Yes, certainly. We will take the photograph of a mirrors. Simple example I will tell. We can't catch that. For example, if you see your image in a plane mirror, are you able to understand what I am saying? If you are in front of a plane mirror and your image is there in the plane mirror, you can't catch that image. But with the help of a photograph, with the help of a camera, can you capture the picture or not? Certainly we will capture. So we can take the photograph of virtual image, but we can't get on a screen. That's important. Okay, so mirrors is also like that, virtual. It's about optical illusion. Illusion means imagination. Okay, we call it Brahma. Okay, so it is an optical illusion, visionary. Optical means about vision. So with respect to vision, it's an illusion. With respect to vision, it's an illusion. Now how this optical illusion is going to be attained? How these mirages are going to be formed? Let us see. For example, during hot summer days, let us consider it maybe a road, a tar road. Tar road specificity is less with compared to the metal road. Specificity less means it can absorb heat very quickly, in a lesser heat. Less specific heat, it can absorb more heat immediately. Okay, within a short span of time. It won't attain for a long run because the specificity is less. If specificity is more, that can be attained for a long run. Okay. So, less specific. So, immediately what happens? It can absorb the heat. So, tar road is absorbing the heat immediately. So, whatever the atmosphere is there on this tar road, nothing but air, that air will absorb the heat. So, that what happens to that air? It becomes hot. Now, the air which is there on the surface of the road is hot air. What do you call? Hot air. What about the remaining places? It's about cold air. Cold air. Now see, cold air, hot air. Cold air is having one refractive index. Hot air is having one refractive index because the density is variated. Density, optically denser and optically rarer. Now this hot air is optically rarer and cold air is optically denser. So dense means what happens? It will come down. Hot is less density, it will move up. Okay, so here hot air is moving up. Hot air is moving up. And what about the cold air? Cold air is coming down. So on the surface of here, on the surface of this, hot air is coming, cold air is like this. Cold air is coming, hot air is moving. So all the media has suffered here. All the media has been intermixed here. Now what is happening? The light ray is coming like this. Light ray is coming towards this. So from where it is coming? Cold air to hot air. Remember that? Cold air to hot air. Which is denser? Cold air is denser. Now the light is going from where to where? Denser to rarer. Denser to rarer. So many light rays are coming like this. So many light rays, yes, so many incident rays are there. Out of this, few incident rays, incident angle may be more than critical angle. Okay, remember carefully here. What is happening? The light is coming. The light is incident on this interface. Of course, let us consider maybe the interface, or maybe the interface like this interface means because hot air and cold air are mixing. No. So now the light is moving from where to where? Denser to rarer. Means cold air to hot air. Cold air is high denser and hot air is less dense. So when the light is going from denser to rarer, if the angle of incidence is more than critical angle, then what happens? Total internal reflection takes place. Total internal reflection. So like this, one ray may come, it's like this another ray, like this another ray. Any one may have whose incident angle is more than critical angle. Then what happens? It will be bounced back. It will be bounced back into the same medium. Some may be refract like this. Here refraction is going to take place because less than critical angle. The incident angle is less than critical angle, so they may be better. But what about here? Okay, so what is happening here? They are bouncing back. Few rays are bouncing back. If the observer is here, then what happened? Here may be anyone, of course, let us consider maybe a tree. Like this, a tree is there. Now it is total internal reflection. So if you see this one, this is the thing, this is the ray which is coming like this. So he may absorb the image is like this. The tree is going to appear like this because he is observing from here. It is the total internal reflection. You know the reflection. For the reflection is going to take place. For example, let us say it is a plane mirror. From this plane mirror, object is here. In this plane mirror, you are going to observe. If you are going to see in front of your plane mirror, your image is there in the plane mirror, in the mirror outside like that. Here also the same thing is going to happen. Here this is totally internal reflection now, so it might be appear like this, but it is totally illusion. Totally illusion. Okay, but when you go and see there is no tree. There will be no tree. It is going to happen in deserts also. In deserts. Tar road also sometimes water is going to present on the surface of tar roads. But when you go there is no water. All these are optically illusions because of TIR, total internal reflection. So what is the phenomena behind the mirrors? TIR, total internal reflection. So mirrors is an optically illusion. Mirrors is an optical illusion. Okay, how it is going to happen? During hot summer days, the surface means interface, or whatever the body you are going to be concerned, in the desert, the soil, in the tar road, okay, the surface. What's happened to that? It will absorb a lot of heat. So whatever the atmosphere or air is there, that gets heated. So that what happened, its density is going to reduce. Less density, so that it wants to move up, and hot air is less density and cold air is having more density. It will come down. Hot air is moving up, cold air is coming down. And two different media. Hot air is one medium and cold air is different medium. So different media is there. When they are going to interact with each other, we call it as interface. When the light rays are incident, out of that any few light rays, critical incident angle is more than critical angle. Incident angle is more than critical angle. Then what happened? They will totally reflected. That total inter-reflected ray, when you extended that one, it will give that there may be something. Okay, the image is going to, like water may be there, okay, like tree may be there. Like that, our illusions are going to take place. It's what important concept behind this theory. So, half mark may come or maybe 1 mark may. What is the phenomena behind this mirror is TIR, total internal reflection. Okay, ma? Right. Now, one more about optic fibers. Okay, so one more thing is there about optic fibers. Okay, so we will see that one also, optic fibers and their applications also important. We will see that one also. Okay. Short please. Yes. Okay, optic fibers. Optic fiber. So, generally when you go to the hospitals and somewhere else, you will observe these things. Optic fibers. Commonly, the children who are going to suffer, or maybe the people who are going to suffer with some ulcer. At that time, they will do endoscope. Okay, so you can easily observe what is going on inside. Okay, when the endoscope, the tube is moving and the pipe is moving into the intestines, it will capture the picture. On the screen you can observe, okay, where it is moving, how it is moving, what is there inside, okay, whether any wounds are there, any trouble is going to happen to that one, okay, in that intestines. All those things can be easily identified with the help of that pipe. So how actually it's going to happen? Because this optical fiber, these are made up of with very thin glass rods, about the radius of 10 to the power of minus 6 meters, 10 to the power of minus 6 meter, we call it as a micrometer, 10 to the power of 6 means megameter, okay, it's about micrometer. So the radius of these pipes, okay, if you are going to consider those pipes, let us consider maybe the pipe, a glass pipe like this. Okay, very thin now. What is the radius? 10 to the power of minus 6. 10 to the power of minus 6 means when you take a meter and it has to divide into 10 to the power of 6 parts, then you will get very minute one. So like that, very thin glass rods or the glass pipes are there, they have been arranged like this with the help of a cable. Okay, with the help of a cable, that's what you call cladding. This is what is called cladding. Okay, so here these are having plenty of pipes like this. if you consider a single one whose radius is very less, 10 to the power of minus 6. As the radius is very less, when you project the light, then what happened? Because of this very less radius, it will touch the wall with an angle of more than its critical. Incident angle is more than. So that what happened? Again it will enter the same medium. Again like this, again like this, again like this, again like this, like this, and the information has been captured into the outside. Here the image you can observe. Here may be the object, and here may be the image you can easily observe. There may be the object, and here may be the object. Okay. So for this, what you are noticing here, if this incident angle suddenly it will be more because the radius is very minute. Because of the less radius, when you are going to insert the light, its angle of incidence must be more than critical angle. So immediately with respect to this wall, immediately it will be bounced back to the same medium and the information can easily capture. And where we are using this optical fibers? Okay, so many uses are there among these applications of optic fibers. Okay, commonly for 2 marks they are going to be asked. Most probably we are using it first one. Endoscope. Endoscopy, you know about endoscopy? To study about the internal parts, whether they are properly functioning or not, any damage is going to happen. So, endoscopy. Okay, so in the purpose of endoscopy we are doing. Where we are using this optical fiber means in endoscope. Because you are observing, you are sending this pipe and will capture the picture and will send to the screen. With the screen we can observe what is the nature of the particular organ. Okay, so in endoscopy we are using, and next one we are using in communication signals. Sending of communication signals also we are using this one. Okay, communication signals. Of course, pipes are going to be used. In this communication signals we are using. In our textbook there is given as 20,000 lines are going to be used, but nowadays it's more than 20,000. More than 20,000 we are nowadays. Sorry, 2,000 are given the textbook. Now we are using more than 20,000 also. Okay, so where we are using this? Yes. What is that? Communication signals. If we are using in endoscopy, communication signals. Okay. And when you see internationally from one country to another country, sometimes you have to send transact information. At the time they will use telecom pipes. Of course, nowadays we are not using this, but one of application has given. So telecom pipes will be used in the case of if you want to send through seas or water or the basins of water and etc. we are going to use this telecom cables or pipes. Okay. And last one is also there about photometric sensors. Commonly in movies you are going to observe whenever accidents are going to be happen to any person or seriously injured, then immediately in the ICU unit they are going to keep some instruments on the chest, on the neck, on the nose, and etc. Okay, those are photometric sensors. Photon is light, measurement. We are measuring the light and we give the sense whether heartbeat, especially heartbeat, functioning of the heartbeat and functioning of the brain. And it's the most probably photometric sensors are used to identify the pulse rate, nothing but heartbeat. Okay, these are the applications of optic fibers. Probably 2 mark question. We are using this in endoscope to identify the internal organs, how they are going to function. Then in optical communication. Okay, optical communication signals also we are using. According to our textbook, 20,000 signals. And telecom cables, especially from one country to another country. Under the seas, we have to send up telecom cables are going to be used, and photometric sensors in the medical field to identify the heartbeat and etc. Okay, so this is also application of T TIR. So optic fiber also works under the principle of TIR. The basic principle behind the optical fiber is TIR. Okay, now let us see. Three things we observe. That's brilliance of diamond. The brilliance of diamond is because of TIR, and mirages are because of TIR, and optic fibers. The basic principle or basic phenomena behind the optical fibers is about TIR. Okay. So besides this, four more uses also there with the help of optic fibers. And besides this, one question is given based on the aquarium. Why in aquarium you may see the air bubbles. In aquarium the air bubbles are going to appear shiny in color. What is the reason behind that? Such questions are also going to be asked. There is also, what is the phenomenon behind that? TIR. Because in the aquarium the light ray will pass from denser to rarer, water to air. Water to air bubble is there. No? So when the critical angle may be some x, if the light incident more than the x, then what happened? The light will bounce back to the same medium, so that they are going to be appear shiny. Let us see that aquarium also. Hi children. So commonly, one applicative question is going to be asked like this. If you see the air bubbles in this aquarium, they are going to be shine as a silver in color. The question is given like this. What is the phenomena behind this silver color? Can you see? What are these? Air bubbles. And what about this? Water. Water is a denser medium, whereas air is a rarer medium. Now the light is coming from denser to rarer. Denser to rarer. When the light moves from denser to rarer, what happened? The refracted ray will move away from the normal. If the incident angle is more than the critical angle, then what happened? Very good. Total internal reflection takes place. That is the reason behind this, the shining of these bubbles. Okay, so why these are going to be appear? Because of TIR, total internal reflection. Now the light is moving from denser to rarer, means from water to air bubbles. Now this air bubble surface is going to act as a reflecting surface. So total internal reflection takes place. That is the reason behind this, the shining of this air bubble. Okay, one of the important applicative question. Once focus that. Children, up to now we see so many examples for TIR. Now let us see the applications of refraction. For that we need a lemon. For that lemon is lemon. Now see, let us observe the size of the lemon in air. Now we have to observe the size of the lemon in water. Air is one medium, water is another medium. When the light is traveling, nothing but object is going from one medium to another medium. What is happening? See the size of the lemon, it's increased. Why the size of the lemon is increased? Because of refraction. When light travels from one medium to another medium, observe the size. When it's enter into the water, its size has increased. Okay, so because of refraction, it's going to happen. Okay, and the question may be asked like this: why the stars are appear twinkling? Why the stars appear twinkling? Because of refraction. Multiple refraction, you can say. Because the light is coming from so far away. In between this, when they are entering into the atmosphere, they have to suffer a lot with a different medium. Okay, so that what happened? Multiple refraction takes place. So that the stars will appear twinkling. Half mark question they were asked. But one more thing. Then why not the planets? Why the planets are not going to be twinkling? They are going to appear. As for example, take moon. The moon is not twinkling. Here two reasons are there. One is those are very close to us. What is it about? Those are very close to us, and the planets are not self-luminous. They are absorbing the light and reflecting. With compared to the absorption of the light and emitting of the light, and they are sending the light into the atmosphere comparatively very less. Because of the reason, the planets are not going to be twinkle. Of course, this question is given in the competitive examination also. And one more question also given. The star which is above perpendicular to your head, it won't twinkle. Why? Already I told you. two conditions. During two conditions, the light does not bend. What is about? When the light travels perpendicular and the media is having same refractive index. It is exactly overhead base perpendicular. When the light is moving perpendicular, then there is no deviation. When there is no deviation means only apparent depth is going to be changes, but there is no suffering. That's a straight, they are moving straight. So the light which is coming overhead from the planet or maybe a star, it won't tilt. Exactly because it's perpendicular, the light is traveling like that. So like that applicative questions may become, but you should be capable to answer if you learn the concept. Okay, so that different natures are there for the applications of. For example, in our school mostly in January or February we are going to conduct campfire. During this campfire also you can observe the person who is there other side of fire. You are in this side and your friend is in the other side. If you observe his face, then what happened? It's going to be shuffled, it's going to be shriveling. It's going to be shriveling. Okay, why? Actually its face is shriveling or going to be damaged. No, because of change of the atmosphere. You see, when you are in the campfire base, what is happening? Hot air and cold air. Hot air, cold air, hot air, cold air is mixing. Means hot air is having one refractive index, cold air is having one refractive index. So when you are going to observe from one medium to another medium, when the light is going to travel from one medium to another medium, what happens? Bending is going to take place. That is the reason why your friend face is going to bend. Actually, it's not going to happen. That is also the application of refraction. So like that, multiple examples are there. But when the question is given once, you have to read the question properly, then you can be capable to get the solution. Okay, don't forget the applications of TAR, applications of refraction. Okay, children. Okay, now we will go for that an important activity in the coming class about glass slab. I think you have understood the concepts of today. What is that? Applications of TAR, especially brilliance of diamond, mirrors. One more question is that can you capture the mirrors with the help of with the help of a camera? Certainly. And of course, optical fibers. Here, optical fibers, the basic principle is about, of course, so many principles are there that, but basic principle is about TAR. Okay, and the applications. In endoscopy you are using, and telecommunications you are using. Okay, those uses are also important. Brilliance of diamond. And why the bubbles, air bubbles in the aquarium is silvery. Okay, and why the lemon is bulges. Lemon is bulges is about refraction. That bubbles is about total internal reflection. Okay, so don't forget that relations. Stars appear quickly because of multiple refraction. Lemon is refraction. And about stars, that is also about refraction. Okay, right. Have a good day.